Okay, so we're going to look at Lisp, and I've already given you a tour of Lisp, and you've started on your implementation, so you understand Lisp to some degree there. And if we were to just look at, programming in Lisp, that introduction I gave was probably enough for you to go to the Common Lisp Manual and go and understand how Lisp works. Okay. So what's going to be different in what I'm going to talk about is that I'm going to actually talk about implementation. Okay. This is how you have to do. So let's go and try to do, apply the concepts we've seen so far. Okay, so let's do some programming. And now that we know all the implementation, at least we should understand how Lisp works. So I go and say set q. We can set q variables to values. Okay. We've looked at lambda definitions. We looked at lambda applications. So it makes sense to compose assignment with lambdas. So it makes sense to go and, which we haven't done before, set q a function name to a lambda definition, lambda expression. Okay, and if you set q that, then you might want to go and apply that lambda later. That's now from anonymous you become non-anonymous. So you want to go and apply that. So you might want to go and do something like this. So we went and created a lambda expression with one argument, and then I go and call that with one argument. And what's going to happen if I type this in? Yeah. Okay, undefined function f. That's what you get in C Lisp. In Andrew's code, you might get an exception, stack trace. Okay. So what's going on here? Can we explain that based on what we've seen before? Or let's just go further. So we could do this. Actually, my slides have got a little messed up, I think. I meant to do Funcall F1 there. So we can do a Funcall F1 rather than F1. There's a mistake there. I hope to correct it. By the way, when I create the videos, I might or might not be able to be correcting all these things. So I'll try to go through the slides with a lot of slides. So you might just have to rely on my audio to figure out what is wrong. Okay. But I should really have done Funcall F1. So that's what Lisp asks you to do. But we could certainly define our own Lisp that goes and looks up the first name, sees whether it is, and goes and looks up the values, sees whether it is a lambda or a non-lambda value. Okay. And does the lambda thing with it. So we can certainly have defined Lisp, and we can do whatever we want in our implementation to go and have the semantics that is shown in the first box, F1. So the question is, why didn't we do that, or why did the Lisp inventors not do that? Why have this long-winded way of doing things where you say Funcall F1 rather than just F1? Okay, and that's the question I posed last time, and Nathan answered it, but nobody else did. Somebody else want to go and answer the question right now? Why have this Funcall F1 rather than just F1? What benefits do you get from that? You certainly have to type more, but conceptually, do you get some more power by doing so? And the examples here are showing you the power, actually. So what I'm doing in the second example is that G has not been assigned a lambda expression, right? G has been assigned F. So G evaluates to a lambda expression. It has not been assigned a lambda expression. Okay? So what happens with the first argument is the first argument we never evaluate. First argument in an application we never evaluate. Okay, and we saw that if you want to go and assign set q, if you want to assign a variable, also we don't go and evaluate the variable name. Okay? So that part is not evaluated. The remaining arguments can be evaluated. The first argument is used to find an evaluator to evaluate. Right? So, if you want an expression for the function and not a name, if you don't want a name, then you should really pass it as an argument to something called Funcall. Funcall will be an identifier, which will have an evaluator. That evaluator will go and evaluate its second argument, which is this expression, get back a lambda expression and apply it. Okay? So this gives us far more flexibility than if we were to go and just do F1. When we look at define, we lose that flexibility, and we'll say that that variable better have been assigned directly a lambda expression. Okay, and only a lambda expression. Okay, actually be a function expression, which is a little different than lambda. But here, when you do setQ, that can be assigned anything. It can be assigned a value, it can be assigned a lambda expression, and we don't want to go and figure out how to evaluate it through an evaluator, so we just go and do Funcall. The Funcall evaluator will go and do the necessary thing. Yeah.
So the correct answer for why we went to Funcall instead of not having it is matched out with the first argument.
Yes. Because the first argument is used to find a definition. When you do Funcalls, it'll look up but not evaluate. Okay? And another way to put it is that we don't want to do a little switch saying, is this a value or a lambda expression? We don't want to go inside it and go and try to figure out whether it's a lambda expression or a value. So we just want to go and look up an evaluator that will go and do the necessary thing. And so, okay, so but the first reason is the real reason. Okay. Questions? I mentioned this earlier, and we'll talk about this later in great depth in terms of programming languages. But there is the L value and the R value of an identifier. And in compilers, the L value is its address, and the R value is its value. So to get the R value, we evaluate it to convert that into an expression. To get the L value, we just find a location. In compiled language, that's an address. In our context, that's a key of our scope. So sometimes the name is used for one thing, and sometimes the name is used for expression. So when we use it as the first argument, we are looking up essentially its L value, a slot. We are trying to find a slot in the environment. And when we use it as a second argument, we are trying to evaluate it. So we're trying to create an expression. Okay? So this L value and R value idea is being applied here. Okay. Questions? Okay, which is what I'm saying here. Yeah, my animations are all off here. So we will not get the problem eval undefined function. I'll try to remember this right after class to change. Okay. So we know these two, what we see so far what we've done is we've evaluated, we evaluated expressions where f is an identifier atom and that atom is a basic function or a set Q or a lambda. Okay. Now we've got to add Funcall to it. Okay. So we have two parts in our expression. One is f is an identifier atom, and second is that f is a lambda expression. So to support Funcalls, that's the next problem. Okay, so we know what Funcall does, and by the way, looking at the time, we will need the next class to cover the worked examples, so you will have to remember things from Tuesday to Thursday, we'll see. So we have two forms that we are worrying about, and now we have this new functionality, Funcall, which we have to implement, which you have to implement in the assignment, and we have to sort of discuss here. and the funcall falls in the first category. Okay, so we can just write an evaluator. We don't have to go and change our S expression. Okay. And writing the evaluator should not be hard. I asked you guys to implement it without covering it in class. I asked you to implement it before today because I didn't think it was too hard, but we'll go and look at it now. So we know how to apply lambda expressions to arguments already, right? We have that thing done. And now we're going to do a funcall that essentially does that for us. Okay, so lambda, if the anonymous function was given to us, we know how to provide arguments to it. We go and change the scope. We go and call the body. Now we have gone and done a set queue before, and we have to go and do a funcall. So what should a funcall really do? What should the funcall evaluator do? Abstractly, if I gave you this as one of those creative questions in my exam, you know all these things, you've never seen funcall before, here's the semantics of funcall, go implement funcall. Robert?
Follow function.
So what does that really do? So tell me the steps involved there. Okay. Yeah.
Evaluate arguments given, put them into a new child environment, and evaluate whatever function is given.
Okay, so we do, okay, so we do these tasks we did also in lambda application, right?
Yeah.
So what changes in funcall?
There's a lookup step.
There's a lookup step. Okay, and that lookup step is really a lookup, or is it's a?
That's why I said italic quotes.
So if it's an identifier, it's a lookup. But I can also do funcall of a lambda expression.
Right.
Yeah.
So if the second parameter is lambda expression, you just evaluate with the third argument.
So what we essentially have to do is to evaluate the second argument. If it's an identifier, that will involve a lookup. If it is a lambda expression, it will be just evaluating the lambda expression, and if it is maybe even a return value of a lambda, okay, who knows what all it can be. And do I evaluate in my funcall the arguments I'm given? So let's go and see. This is the structure. We've got funcall f e1 to en. F can be a lambda expression directly. It can be an identifier. Okay. So we need to use f somehow. Okay. We need to use the arguments e1 to en. Okay. So now you guys have said it already, but fill in the blanks now. What do I do with f? Evaluate it, actually they should have had, sorry, yeah, again an error. I forgot the environment here. Okay, so in general, if I don't give an environment as an argument, that means the environment I got. Okay, so thank you. Eval it with the environment. And what do you do with E1 and En? Evaluate. Well, let me first be maybe lazy and wrong. So I really want to go and create a list, right? Where the first argument is the value of f, and the remaining arguments are the arguments to f. If I create this list, what am I going to do with that list? I'm converting this into a lambda application. I already know how to evaluate lambda applications. I don't want to redo the work. Ideally, okay, if you guys code it not so nicely, you might redo the work. So I'm creating a list. I'm creating a list that is an application and just saying, hey, evaluate in the environment. That makes sense, right? It's just like inline substitution. That I had this, we know how to go and take a lambda expression and apply it to arguments. I'm given a name for a lambda expression, evaluate that and put that in a list, which is, and then I go and ask it to evaluate itself. Yeah.
Possibly you already have the E1 tree and the S expression, S, which is S dot get tail dot get tail. Right? Then we just need to create a new S expression with F dot eval as a 10 and the get tail as the new instance tail. So that will directly create this list.
That's what I'm doing here, right? I'm creating a news expression. This is my pseudocode. I'm doing a list. I'm creating a list where the head is that value of the lambda, the eval of f, and the remaining elements are the elements that are the arguments. That's essentially what I'm doing. So you paraphrase what I said. Okay? And I'm asking to eval. So I've done the harder part already earlier. And this is what I'm saying is like a macro substitution. I'm just replacing that f with that, what its value is, and saying, oh, we already know how to go and do a lambda application, so let's do it. So when I went and explained lambdas to you guys, and anonymous functions that is applied immediately, they're kind of boring. You can't do anything interesting with them. But conceptually, we've learned, if I'm taking a layered approach, I've conceptually taught you, what that means, and now I can just go and put another layer that goes and remembers names and just uses the same concept. Okay? So from a layered point of view, those lambdas were interesting. On their own, they were very boring. Okay? Because we couldn't do anything useful with them. Okay? But now I can do something useful. I can go and do this inline substitution. Where did the lookup happen? Where did the lookup happen? Anybody else want to answer that? Sorry? F.eval. F.eval will do that. Okay. If I just type a variable in Lisp, it will look up. So that's what we do. We did that a couple of lectures ago. Okay. Did I forget something here? That was a question. That was not a statement. It's always a headache, right? To eval or not to eval the arguments. So there's always an issue as to what order you evaluate arguments in. And in functional languages, pure functional languages, it shouldn't matter. But in real functional languages, it is always left to right.
If one of them says E1 is
Set Q.
X, like set Q, it's like a set Q.
Yeah, that's a problem we always face. Even when we did the lambda application, that's always a problem. And but it's done left to right. Anybody want to argue against eval? Sometimes we eval, sometimes we don't eval. Maybe this is one of those times when we don't eval. Why not?
Because the very last eval for an S expression automatically does eval on the rest of the
So the eval on this list is going to take an application and it's going to evaluate its arguments. We already saw that. Okay? So actually, this is a mistake Andrew made. It's a natural mistake to make. And to correct it, he had to go through long hoops. So I haven't coded it. And just be careful that maybe it gets more complicated to not eval than to eval, but conceptually this is what happens. Okay? We know that 2 evals is not equal to 1 eval. Okay? So I was able to break his implementation by putting some quotes there. And so we don't eval here. Yeah, Robert?
I still don't like the F eval, because if F's a lambda, then you're evaluating like just raw lambda, then you're evaluating lambda without setting up the environment. And that works.
Yeah, you'll get back a lambda object.
No. But like if you just give it like a lambda, you still get back a lambda object. No, you won't.
Yeah. A lambda, if you just give it a lambda, you evaluate, you get back a lambda object. So, okay, this list thing is not going to be, so the lambda application expects a lambda input expression. Now I understand why the coding is a little harder. So, the list that I'm talking about expects a raw lambda expression, whereas here I'm giving it back a lambda object. So you'll have to probably do things a little different, where the lambda application and this code will share some code, and I'm actually just because of the way that was coded, because that expected the input expression. Now we're getting back a lambda object. So, but I think that code should work because lambda object asks to evaluate itself with wanted environment. So you'll have to have a little different version of the application than the one I'm showing here. You don't have to worry about the case. And now I understand why his code got a little messy. Okay? So the lambda application code and this code will have to share some common code rather than being just this code. Yeah. No, but the eval will do that, right? The eval will take the list and evaluate. So you know what? I should really, to really make this stuff perfect, I should really say f.eval.toString, and then I'll get back the input expression, and I can go and just to make this code be identical to the previous lambda application, because here we are getting an evaluated lambda and that expected a non-evaluated lambda. But the right way to do that is to do the lambda application in terms of another helper function that takes the evaluated object and goes and evaluates it. Okay, so this is a little ambiguous here. Okay, but when you code it, you'll kind of figure it out. But you get the basic intent that we just use a lambda application. Okay. Questions? Okay, so cascaded eval is not equal to single eval. And in the very worst case, here I'm trying to share the code. In the very worst case, I can just duplicate all the code I had for the lambda application and do it in the Funcall. Okay, but after evaluating f, but we do have to evaluate f. That is for sure. Okay, so in the lambda application, we took the lambda input and asked it to evaluate itself. Here we take this f and evaluate it. Okay, so we can at least go and trace this. So we've set queued f to lambda x plus x1. Okay, so we get back the lambda object here. Right? So this part is fine. Just like our previous set queue, there's nothing different here. We have our environment you know, our global environment has f equal to lambda x plus 1. Okay, nothing surprising here. I mean, there's a lot of stuff to look at, but just trust me, there should be nothing surprising here. Okay, the basic lambda is the lambda object you get, and we set this value. Now let's look at Funcall F3, and you know, I was vacillating between two sets of slides, so just forget the set QGF part. Okay, and just look at the Funcall F3. So we are now asked to go and evaluate Funcall F3. Okay, so the very first thing we have to do is look up f in environment. That's where the eval happens. We were talking about that. Okay, and we find that f is lambda x plus 1. So we create a new expression lambda x plus, this is what we want to happen. Okay, we created a new lambda x expression with lambda x plus x13. So we basically did an inline expansion of f to that. Okay, so far good. Okay, we looked up ID, we got back this particular lambda object. Okay, not an input expression for lambda, but the lambda object itself. Okay. Now we go and evaluate the argument to that in the environment, 3 values of 3. Okay. What's going to happen next? What's going to happen with the 3? You have to create a child environment. Okay. So I might have some inconsistencies here. I wonder if I got the latest version on this laptop. So we go and set the new child, we create a new child, and we also go and, I think I'll repeat this again in the next slide. So there are 2 steps here: create a new environment, and then go and take the formal, get the arg names from lambda, from the lambda body, and go and assign those values in the environment. So I've done this both here right now, but I meant to break that into 2 different slides. But I guess I didn't, which is fine. And then we evaluate the body in the new environment. Okay, so we now evaluate the body in the new environment, which is just plus x1. X happens to be 3, so surprise, surprise, we got 4. Okay, so actually these slides are consistent. Okay, even though I've taken multiple steps and put them into one slide. I have some other tracing, which I'll get to, I guess. But you get the idea? Yeah.
I'm just kind of curious, like, because I know, like, one of the things we talked about was you can serve as a function, right? So I'm just curious, like, when you want to use code or like a lambda expression.
So you can use quote or lambdas. Quotes are unevaluated. So you can always quote a lambda too. Okay, and you can have quotes within lambda. So there are 2 different things. Quote just says, whenever somebody asks you to evaluate me, don't evaluate. Just return what if I'm quote A and somebody wants to evaluate me, just return A. Lambda is saying I'm a function application. Okay. Now I can quote a list that has lambda in it. I think that's what you're thinking. And then you get a lambda, and then you can do fun, interesting things with that. But that's not necessary, because if you just say lambda, it will return the lambda body. But yeah, you can always do quote of a list that you've read, and then say, hey, whenever I'm asked to evaluate, just return this thing, and that's going to be a lambda, and then it will be returned. It will be just evaluated like a lambda object. Okay, 2 questions. Good, Robert.
Going back to Funcall, now that I understand, you're just trying to delegate, basically.
Yeah.
Other delegation methods could work. Like, you don't have to delegate to X expression. You can delegate S expression and Funcall to the 3rd.
In fact, you want to delegate them to a 3rd party, given that we've already got the lambda object here.
Gotcha.
Okay, that's the mistake I made. When you do pseudocode, you can just wave your hands a lot, you know. So essentially, because lambda application expects an unevaluated lambda expression, the input expression, whereas this one evaluate has got a lambda object in it. Okay. Yeah.
So I'm trying to understand the string funcall, just normally calling it, like I understand it, but I want to know what it looks like. All funcall does is does an extra evaluation on the first argument, and then evaluates the rest of it as normal. That's different than just calling F3, which would then evaluate all at once.
No, F3, if you did F3,
Yeah.
the way we've defined it,
Yeah.
it'll say F is not bound to anything.
So it won't look up.
Yeah. F is not a function name. It'll say F is not a function name. Okay, it will look up and say, sorry, okay, not allowed. When you define, you can do it, which is going to come later. So the way we've implemented so far,
Doing the land thing, except you don't use land.
yeah, we look at that. It's much more complicated. Okay, but right now the way our evaluator is written, F should be a basic function, or it should be a reset queue, or a lambda. It can't be anything else. That is the way we define F to be. Okay? Yeah, there's a typo there too. So, the subject of Thursday lecture. So, you know, the stuff that's going to come next is going to put together concepts, and it's not going to introduce any new concept. Okay? If you were to choose between understanding what you already know deeper, or having Andrew and me help you with code on Thursday, which would you choose? And that depth will not be necessary for the exam. So you will understand it deeper. Maybe it is, but indirectly. I'm not going to ask you to go in. So I can't tell what you might learn from that. But how many of you would prefer to have some help with the assignment? Okay, lot. How many of you would like to know more depth, which may or may not help you with the exam? So you guys get outvoted. Okay? But stare at these two things. I'll keep them in the slide and try to understand what will happen in these two cases. If you really want the depth. Okay? And these two examples are going to really motivate assignment 3. Okay? So we'll just, and I'll let you know if whether Andrew can come on Thursday or not. Okay? Okay, so here's our first attempt at Funcall. And we said that, look, we already know how to do lambda applications of anonymous functions. Now we have a named function. So we have to somehow figure out the lambda for the named function and go and apply that. So we already have something that goes and applies a lambda application expression to arguments. And our first attempt was we just make a list. We make a function call. A function call we know is a list. And the first part can be a lambda or it can be a name. So we just go and put f.eval, which is now a name, and that should return a lambda. And we go and pass to the lambda the expressions that we are asked to evaluate, the expressions that we are asked to pass to the function. Okay, so we said, okay, maybe we should go and we have to eval f. We can do lookups of f. But if we do lookups of f, then we are restricted to variable names. But if we want arbitrary expressions there, we want a lambda expression. We should be able to say funcall lambda expression and then arguments. So we want to do an eval, and later we'll see our functions can return functions. So we want to be able to evaluate, apply return functions too. So f.eval is going to be a much stronger thing to do. then we said, hey, we evaluate always the arguments in an evaluator. So maybe we should, unless it's quote or cond, and maybe we should evaluate these too, but we shouldn't because our Lambda application is going to do the evaluation itself, and we shouldn't evaluate twice. Okay. So we saw this problem, and we said that, look, we don't do e1.eval, we don't do en.eval. And then based on something that Robert said, I said, hey, but this f.eval, we have to evaluate f, but we can't just give it to the Lambda application evaluator because Lambda application assumes unevaluated Lambda. So what it does is it goes and takes its input. It expects a form that I've shown above, that there's some Lambda expression that is the input expression, which is applied to a bunch of arguments. And it goes and says Lambda is, it calculates first the Lambda evaluation, and then goes and uses that Lambda. Okay, so it's not quite, it's getting there. I get the basic point, but it's not something we can just use directly. Okay, so as we talked last time, we can have a helper function. Okay, question? And so this is the helper function. It's where we take and write an eval that takes an evaluated Lambda, takes a bunch of arguments, and does everything that the Lambda application did earlier, except it doesn't go and have to evaluate Lambda input. Okay, it just assumes a Lambda atom. Okay, so it's identical to what I did earlier. I just cut off a line, and I have this Lambda. Okay, and it creates the child environment. It goes and uses that child environment in the evaluation of the body of the Lambda. So it does all the good. It creates. So it does all the good things that original one did. Okay. And now my Lambda application just goes and evaluates the Lambda, okay, and passes that Lambda and its arguments and its environment to this helper function, and we essentially get the same effect. Okay, and our Funcall evaluator, instead of evaluating the input expression, it does f.eval, gets the Lambda object, and does the eval. So this is just to correct what I said last time. Otherwise, it's basically saying that we have two functions, two pieces of code that need similar functionality but not identical. So we'll just put that into a helper function. Okay. Questions on this? Okay.